Hey, what's up guys? This is Akshay from AS Learning, and today in this video we'll be seeing about Gemma 3. Okay, so we get a lot of models. Some of them are proprietary, some of them are open. Okay, so OpenAI's model, they are all proprietary model. You need to pay for per token generation. You have Meta, which releases model into open source category. Mistral is open source. Okay, Anthropic is proprietary model closed source. What Google has done is Google's proprietary models come into Gemini series, and they have their open weight series also, which they categorize into Gemma. So we had Gemma 1, Gemma 2, and now recently we have got Gemma 3. Okay, so before seeing what upgrades we have in Gemma 3 over Gemma 2 and via code how to use Gemma 3 in your applications, let's first see a short demo. Okay, so Gemma 3, they have made it multimodal. Okay, so now you can upload images and ask NLP questions on it. Okay, so this is a Hugging Face space, and for a demo purpose I'll pick this one, caption this image. You can see that we have a beautiful cat and we are asking it to caption it. So this is a 12 billion instruct tune model, and yeah, so we can see that here's a few caption for the name of the cat, short and sweet, surprise kitty, funny. So it's good, right? Similarly, you can try other sample given also. Okay. Now we will see what are the upgrades in Gemma 3 over Gemma 2, and then we'll be seeing via code how to use Gemma 3. Okay, so Gemma 3, they have launched in 4 variants: 1 billion, 4 billion, 12 billion, and 27 billion. Okay, they have increased the context window. We have 32K for 1 billion and 128K for 4, 12, and 27 billion, which is very good news. Gemma 2 was not multimodal. Gemma 3 has been made multimodal. Okay, and but the multimodal capability is not available into 1 billion. It is available into 4B, 12B, and 27B. They have also made it multilingual. It supports 140 languages. Okay, so these are some very major upgrades. They have made multilingual, multimodal, increased context windows, and even size variants. Okay, then on ELO score, if we see, Gemma 3 comes into a sweet spot where the number of parameters are also less and the ELO score is also quite good. Okay, so high ELO, low size. And you can compare it with other models like Llama 3.3 comes here, which is of 70 billion instruct. Qwen 2.5, 72 billion instruct comes here. 3.1 comes here. This is Gemma 2, and we have Meta 3.1. We have DeepSeek here. Okay. And as you can see, from Gemma 2 to Gemma 3, there's a very good ELO score upgrade. Then we have a PT model series. In pre-train, you can find instruct tune in IT series and the same things. Okay, 3 major technical enhancements which I already mentioned, including the context length, multimodal, and multilingual. This is the evaluation benchmark where you can see now Gemma 327B instruct tune has a ELO score of 1338. Okay, it's open, the type is dense, and we have 27 billion parameters. Okay, and this ELO score is currently led by Grok 3 of XAI. Okay, and this is just some evaluation on some dataset benchmarks, and you can see that Gemma 3 27 billion is in lines of Gemini 1.5 Flash. Okay, yeah, now this is what we saw, the upgrade of Gemma 3 over Gemma 2. Now let's see via code how to use it. Okay, so first we'll be doing the installation. We are installing the latest transformer version which supports Gemma 3. Once the installation is done, I am using the pipeline abstraction provided by transformers. Okay, model is Gemma 3 4 billion instruct tune. Device I've kept is CUDA. TOS G type is float 16. Okay, here I am passing the image I'll show you the image, and I'm asking him a question: what animal is on the candy? So let's see. This looks like a turtle, right? And asked him question. It downloaded the sharded models, and as you can see a turquoise candy. Okay, it appears to be a turtle, so it gave a right answer. Okay, so this I use the model via pipeline abstraction. Similarly, we have two other ways. One is via conditional generation, and the other one is via causal LM. Okay, so via conditional generation, it's you just need to import it from transformers, give it the model name. Okay, device type here I've kept is auto. Here I'm loading the auto processor for loading the processor. Okay, here I have the image where it's a receipt where I'm asking him the password. Okay, and let me show you the image. So here you can see that we have an image from Ashley Hotel West Coast, and here we can see the password is AAEU. Then we are doing processor.apply chat, where I'm passing him the messages, giving him some parameters like tokenize true, return me, torch tensors, and add generation prompt true. Okay, and then I'm generating it, and I'm just decoding it back again. And here I got the answer that the password is AAEU. Okay. So it's right. While trying Gemma 3 via causal LM, I was getting issues on using collab, so I couldn't run it properly. I also tried, this issue is something related to device type. I tried changing the device type to auto, CUDA and all, but for some reason it was giving me error, so I couldn't successfully test it. But yeah, even I hope this will also work fine. Okay, so generally I've seen people preferring causal LM when you wanna skip the image part and use it as a language model. And if you wanna use it like a multi-model where you will be passing images, at that time we can use the conditional generation, or we can use the abstraction pipeline abstraction of transformers. Okay, so this is what I had in Gemma 3. If you learn something new, just give it a thumbs up and stay tuned to AS for more such amazing tech stuff. Take care, peace out.